Hello, it's David at DCES UK, and once again I'm blabbing about ARC fault detection devices, or AFDDs. You know me, why make one video when I can make three? Speaking of which, my original from the summer of 2018 was a first look. My more recent upload showed off my impressive sounding ARC fault chamber and custom engineered test apparatus, and in this one I'm taking a pricey plunge. Yes, I've procured 9 AFDD units at great expense to retrofit to my own home installation. Why? Well, because retrofit is where the ARC fault arsehole is going to leave the thickest skid marks. At the time of recording, we don't know what 18th edition Amendment 2 is going to say when released in 2022. It may beef up the current wording of 421.1.7, which currently only recommends the use of AFDDs to start mandating them. And if it does, then it will apply to that point forward for new installations, new circuits, and new consumer units being bunged in. Now, the thing about wholly new installations is that if you're rewiring or installing a new electrical installation from scratch, then you're the one designing it, so you know what's where and how it all bolts together. Therefore, the inclusion of an ARC fault device ought not to cause you too much grief, other than financially, which I'll come to later. However, where we're plopping new consumer units onto existing wiring and attempting to apply ARC fault detection in domestic dwellings that previous DIYers may have hacked away at, it might well see us struggling to keep the power on afterwards. I'll be looking at how you can mitigate against nuisance ARC trips later in this presentation. First, let's take a gander at what I've blown my wad on, and here they are, the Wylex single module RCBO with AFDD. If you don't know what this is, go sit through my previous video where I show an AFDD in action. You know, just why are we calling them AFDDs in the UK when elsewhere on the globe they're already well known as ARC fault circuit interrupters, or AFCIs. AFCIs are nothing new over the pond, but are of course often employed on circuits that have a lower voltage and a higher current than is the norm in the UK. As far as I can tell though, they seem to be doing the same sort of job, which is to monitor the frequency of the current, the US unit's looking for a frequency of around 1 MHz according to Eaton, which would indicate arcing down the line and cause it to trip. The technology they use over there, I haven't really seen. There's a video from Eaton linked below where they show inside an AFDD, where all I can see are a bunch of discrete components on the PCB, but a good portion of the enclosed instruction leaflet for my new toys warns against violating the copyright of the driver and source code, suggesting my Wylex devices are software driven, and it's telling that the warning extends to the ARM Cortex-M microcontroller. That indicates what's at the heart of my new Wylex gear. So we're talking about an actual computer in its own right, housed inside each of these units. Gaz and Joe filmed a teardown video of one of these models on the eFix channel, again linked in the description. And although we could see a PCB in there, the only chipset I spotted was a Texas Instruments U28880 as part of the power control. The other side of the unit revealed the rear of a PCB, and I wasn't sure from the eFix video whether it was the same board or not. So I reached out to Gaz, who took some new pictures of their disassembled unit, showing there are indeed 2 PCBs in here, and bingo bongo, on the second one is the brains of the thing, an ST Electronics M32 F401cc ARM Cortex M4 core, 32-bit, up to 84 MHz CPU, 256K of flash memory. This thing runs rings around the home computer I grew up with, and would play a better game of Pac-Man if it wasn't undertaking the comparatively boring task of monitoring my current harmonics. Wowzers. I suspect the American stuff is wholly different inside. Certainly they weren't sticking 32-bit embedded CPUs into $30 devices 10 or 20 years ago. And why does stateside switchgear look so cranky? Look at this. This image is from a new point of sale. The bloody thing looks like it came straight out of World War II and saw some combat action along the way. Fortunately, the beaten up army surplus look didn't make it over to our shores, but then neither did the name, which is a shame. I don't care that not all ARC fault detectors are made equal. If they're all doing the same job, we as a species could at least have picked a single universal designation for them in English. And while I'm moaning about standardization, it's also a pain in the arse that BSEN 62606, yeah, get used to that fucking number, didn't take the opportunity to specify how the status indicators or flags should work. Could we not have had some commonality on what colours they were and what they mean? Just look at this Technicolor clusterfuck just between these 4 models here. Normal indication being red on one, green on another, yellow on a third, and fuck all on the 4th. We'll soon be attending call-outs for device trip events where the installer failed to affix a sticker to the board and we have to go on our mobile phones to find just what some manically flashing multicolour LED is trying to tell us. And let me just say, I spent an hour putting this graphic together, having to scour the internet across different resources just to find this basic information, and even then I can't guarantee this is wholly accurate and it may be subject to change. Notice the absence of Hager? Well, apparently they don't make a combined RCD AFD device at present, so their AFD units are combined with overload protection and shun the use of an illuminated indicator completely. Instead, they have a mechanical yellow flag which will be absent for an overload fault, present on an arc detection, and may or may not show in the event of an external RCD trip. The fire symbol below the flag window supposedly means arc rather than overcurrent, although I would have thought a lightning symbol would have been better. It's not like an arc can cause a fire but an overcurrent can't. At least Hager have this information if you know where to look for it. And it took me a lot of searching with different keywords to dig this PDF bastard up. For anyone unfamiliar with the model, you wouldn't know there was a flag there cluing you in on the nature of the fault, and basic searching at this time yields nothing obvious on their support or technical websites about it. Regardless of the manufacturer, a search for AFDD should bring up immediately a page explaining what any indicator or flag means, because that's what Joe homeowner or Jill electrical contractor is going to want to know. Nobody's going to think twice about these things until it trips. So the most basic of searching should bring it front and centre instead of the goddamn marketing blurb. This page, for example, dates back to 2018 and pertains to a device used in Germany since 2016. So why is there nothing here about what the flag window shows? Am I supposed to select the specific product from the range? Oh, you gotta be fucking kidding. What about my Wylex models? I mean, I know what their indicator means and that I've bought the fucking things, but if I were unfamiliar with them and facing an LED which inexplicably is red for normal operation, what happens when I search for quick answers is I get another page of marketing blarney about what AFDDs are and how they're going to save my life. You know, the status indicator information can be included as part of the marketing bollocks. There's nothing stopping any of them from saying right here, our model has an indicator or flag which will be in one of the following states to aid the installer or maintainer in diagnosing a fault. These brands have all gone to the effort of building this functionality into their devices. They should be shouting about that. Fuck is this? We also discussed the most populat questions on ARC fault devices. Well, okay, I'm all for having my populat questions answered, thanks very much. Let's take a look at their dedicated section on AFDDs. Son of a bitch. This isn't good enough. It's not acceptable for these big brands to be telling me to put my money where their mouths are in order to provide this expensive protection when they're going to leave me clutching my Metrol in one hand and my dick in the other when I'm out on site at fuck you o'clock in the morning trying to figure out what their fucking equipment is trying to tell me with its lights or flags while their technical support teams are all tucked up in bed with their blow-up dolls or teddy bears. You've got to be shitting me, Schneider. You want me to pull what I need from out of a zip archive? Do I look like I've got cunt written across my forehead? Somebody tell them it's not 1998 anymore and they can update their website now the whole Y2K thing has passed. Here's Eaton doing things almost right. An application guide with handy flowcharts, if you know where to look for it, although it's still a goddamn PDF. All manufacturers should have this readily available, readily accessible and easy to find from a mobile browser when it's needed on their website, not buried in a downloadable PDF or a fucking zip archive. But yeah, it's a shame the differences are so great between manufacturers in how these things report their status. There was no domestic market for these, it's entirely new, and we perhaps had the opportunity to standardise from the start. But I don't know, maybe that's too simplistic. Anyway, as usual, those who specify the standards are not those who face the flak. They're knobheads with letters after their name. Well, people usually stick 4 letters after my name, but it's not something I boast about. Anyway, going back to that American video of the Eaton product, one thing of note when they showed the internals of their AFCI was the presence of metal oxide varistors to protect the PCB from surges, something I didn't see in the eFix teardown of the Wylex unit. So if you're putting this kind of technology in, it has to go hand in hand with surge protection at the board, if you ask me. I'm certainly not risking my expensive investment today without an SPD present at the source of my installation. I'm about to install 9 computers into my consumer unit, which sounds ridiculous when it's said out loud, but I don't want them flashing a failed self-test at me whenever next door fires up their knackered jet washer to clean their car. The reason I'm retrofitting these ArcVault devices into my own home is to see what the pitfalls, if any, may be in applying such equipment to an older installation. And this, of course, is an installation I'm familiar with and in control of, which makes it ideal for the test. It's a late 1960s property which we moved into in 2002, so its history for the first 40 or so years is largely unknown. A single-storey extension was built onto it in that time, but I don't know if any previous owners fancied themselves as being budding Sparkies. All I can tell you from when I moved in is that they had a gash-tasting wallpaper, the carpeting was dark green throughout, and they liked their woodwork stained diarrhea brown. Electrically speaking, I've no reason to think they dabbled with things they perhaps shouldn't have, as I haven't had to go around uncocking anything over the years. Of course, since me and my bitches moved in, various works have taken place, including relocating the kitchen from the front of the house to the rear in 2005, refitting it again in 2018, a new and extended bathroom, also in 2005, new feature lighting throughout, because, well, that's what I do, a removal of the gas services completely, so all heating, hot water and cooking appliances are now electric, plus there's been a garage conversion in 2004, there's an EV charger, an instant boiling water tap, which is fucking magnificent by the way, a positive pressure ventilation system and a solar PV installation, all of which serve to make this perhaps a more exciting installation, at least electrically speaking, than many. The wiring here is PVC copper, and it was still on its original BS3036 rewirable fuse box, similar to this, when we moved in. We had the garage converted in 2004, at which time the fuse box was replaced with a 16th edition MK Sentry consumer unit, like shown, containing 1 RCD and installed by whichever electrician the builder at the time appointed to the task. When I started this business back in 2012, I took the opportunity to relocate my consumer unit from its old position up near the ceiling down to where it is today on show, and I also upgraded it from a 16th edition to a 17th edition dual RCD configuration. I plumbed for this Wylex board for one reason: the transparent cover. Being hard for electricals, as I am, I want the dog to see the rabbit without having to finger around the flaps. Before I undertook this upgrade, about 8 years ago to the day as it happens at the time of recording, I performed a full EICR on the installation with a fine-tooth comb, as I was using this installation as part of my first competent persons assessment, with NAPIT as it was back then. Paranoid as I was that they'd haul me up over something, I went through everything in the house to ensure there were no loose connections, no duff numbers, no shoddy workmanship, and that everything tested and added up to the maths. In short, for an installation where arc fault detection is now being installed as a retrofit on an installation others have designed, installed and maintained, or not over the years, well, this is as good as it gets, and I'm as confident as I can be that this remains about tip-top for its time. So, will retrofitting arc fault detection result in any new tripping trouble that my existing overcurrent and earth leakage protection isn't otherwise upset by? Before I begin the upgrade, I'm going to undertake a wholly new and very thorough bout of inspection and testing to repeat that of 8 years ago, and to compare the numbers to see what's changed. Numerous additions and alterations have been applied since my 17th edition Wylex board went in, from wholly new circuits for smoke alarms, solar PV and EV charging, major alterations with the kitchen revamp in 2018 and the switch from gas heating to electric, which means panel rads, underfloor heating and a storage heater have all subsequently gone in, down to minor works such as new lighting, a replacement shower and accessories which just didn't exist back in 2012, like USB sockets having been installed. I want to be as sure as I can be that after fitting my new arc fault devices, they're not going to trip off whenever I go to make a cup of coffee. One alteration since my 2012 Wylex board went in is the inclusion of 2 other consumer units, DB2 and DB3, which have themselves both appeared since 2017. This one we've seen before in my videos about the Garrow priority board, which allows my EV charger and electric shower to share the same 40 amp circuit so that my maximum demand is kept down. If I plug in the wife's electric car, then the car itself won't try to charge until after 2 AM, unless it's manually overridden. But should it be on charge and someone fires up the electric shower, then my shower takes priority and the charger clocks off. If both were on together, there's a risk my measly 60 amp main fuse would blow, and yes, I am only on 60 amp here despite all the electrical whistles and bells. This second DB is an overrun, as new circuits have gone in since DB1 was installed. A wired smoke alarm circuit, the solar PV system, which I installed myself in 2014, the surge protector I installed in 2018, a 20 amp circuit for electric heating, which shows various radiators and underfloor heating mats upstairs, and the immersion heater for hot water, which, although an original circuit in the house, was never connected to the 16th edition board or to the Wylex replacement back in 2012. It only got reconnected in 2014 when my gas system was decommissioned. Anyway, I ran out of room in my original 10-way board, so this one got thrown against the wall as an expansion. My aim here is to retain the existing CU enclosure and to change the contents within. That's not something you'll likely do out in the real world, as it would make more sense to fit a new steel enclosure. But I'm sticking with my insulated board for a number of reasons. Firstly, I want to retain my transparent flap so that I and my visitors can see these expensive new devices. Think of it as a conversation piece. David, why do your protective devices all light up like a Christmas tree, they'll ask. And piss off, you nosy bastard, will be my drunken response. But yes, I want to see these things. After all, I've paid enough for them. And cost is a second reason. Why should I fork out to replace my perfectly sound enclosure with a steel one? I would if it were a customer site, of course, because I do my best to comply with BS 7671. But this is my property, fully inspected, tested, maintained to a good order. It's not in an escape route, and it is about to be outfitted with the very latest in protective devices. Sure, plastic doesn't contain a fire as well as steel might, but if it's properly installed with the correct rated devices, all torqued up, and those devices are type compatible with the enclosure, as Wylex have confirmed to me in writing that these are, then why should it be at risk of spontaneous combustion? Do I need to spunk out tens of quids on a metal box? Do I bollocks? And yes, I have paid for these AFDDs out of my own pocket. There's no sponsorship or paid promotion going on here. When Electrium got wind I was doing this, they did initially half offer to help out, perhaps in return for my interviewing their technical people about AFDDs to maybe put to rest a few questions or rumours, which I was all up for. But I think they were perhaps confusing me with one of the more family-friendly channels fronted by polite pretty boys. Because once they sussed it was me asking questions about their AFDDs, well, you just watch them turn the colour of boiled shite and quickly recant their offer. Still, I can't be too down on Electrium, at least they have engaged with me. They also supplied my original AFDD module, as seen in the previous two videos. Schneider and Eaton, on the other hand, have never shown any interest, despite my reaching out to them. And that's a shame, as I'm not out to do these things down. There are concerns and questions we all have about them, but I'm just going to tell it as it is. So for manufacturers to shy away from engaging in an honest look at how these things are going to affect the lives of we who have our arse in the grass merely serves to deepen our mistrust in what already sniffs to some of snake oil. So yeah, cost. And my thanks to George at Gillec, who found me the best prices on these, but was unable to secure stock in time for the making of this video, and to CEF, who had the ready stock and did me a favour on pricing. Cities are my principal supplier, as I've said in the past, and my local branch do look after me. I've got a good relationship with them. Even so, the 9 AFDD units I procured here have cost a pretty packet. In fact, I believe my accountant broke it down for me. Let's see. Apparently, it's equivalent to 673 cans of special brew. Oh, I seem to have passed out for a moment there. I am sorry. I was reading this missive from my accountant, as I recall, which says it's also equivalent to 81 bottles of Jack Daniels. Yeah, even with a goodly discount compared to the public pricing like this, it's still a 4-figure fingering of my wallet in 2020 money to level up my circuit protection. If you're Joe Loser and you don't have a rapport with the staff at your wholesalers, then you'll be paying the sucker price for this gear, which at the worst end, where I've seen these things going for £180 a pop, would have today's upgrade costing around the £1,700 mark, which is quite ridiculous. So, you know how I don't put mid-roll ads into my videos on YouTube? Yeah, well, this sucker's an exception, and I'm sorry for that, but there's a fat AFDD-shaped hole in my bank balance I need your help with. What do you mean you've got an ad blocker? Oh, fucking cheers. Look, if you want to watch my rubbish without ads, go stick it to YouTube by visiting my library channel, where all my content is replicated advert-free. Anyway, if you want an honest video on ARC fault detection in a real-world UK installation, where else are you going to get it in 2020? The manufacturers will, no doubt, start engaging with people on social media through 2021 to get their message across. But all you'll see on Instagram or whatever will be pretty installers putting them in pretty new installations where nuisance tripping won't be seen and where the hardware has been supplied for free in return for positive press. In fact, if I see such smarmy nonsense popping up in my feeds, you can perhaps expect some piss-taking or maybe even a cheeky reaction video. For those of us on the dirty end of domestic retrofit, where you may find you have to shoehorn this technology into existing installations, what's going to bite us on the arse? That's what I'm aiming to find out. And that's the final reason for not changing the enclosure. This is a retrofit challenge. You may have to fit these into older boards out in the wild. For example, on a wholly new circuit on which AFDD protection is required, but where you're not tasked with changing out the existing CU. The aim then is to depopulate this upper board from its current dual RCD high integrity configuration, link the 3 neutral bars together as one, replace the 3 buzz bars for a single one, and to populate it with my 9 AFDDs. A 10th circuit, a basic 40 amp breaker, will continue to supply this lower board, which will retain the surge protector and its associated MCB, plus a 16 amp breaker to supply the feed to my twat cave wall of death, as I don't want RCD protection on that at this end. If I'm demonstrating an RCD or earth fault in the twat cave, then I want that to happen over there. That's fine, as the supply cable to that is surface mounted, so it doesn't require RCD protection. And yes, it is SY cable, which is not approved for such use, but it's adequate for the task here. Just trying to find the right model of devices for retrofit has been a head spinner. For goodness sake, don't try and keep up with what I'm about to rattle off here. Suffice to say, I spent an afternoon wrapping my hangover around just what I needed to order in for this project. Ready? My existing protective devices in DB1 are of the NHX range, which are compatible with either the balcony style or flexible cage connection buzz bars, DB2 being the former, outfitted with NSB model devices, while DB1 has the flexible buzz bars and NHX devices. However, in trying to find the right AFDDs to retrofit here, I assumed the NSX range of AFDDs would be the ones to go for, yet George at Gillec identified the NHX SS models as being right for the order, but I couldn't find any data on NHX SS, only NHX SC, which is the combined 2-module unit shown in my previous videos that I didn't want as I was after the single unit. So if the C in NHX-SC means it's this combined unit, it stands that the S in NHX-SS is probably the single unit. Therefore George seems to have identified the correct product, and although I couldn't find any data on it, Electrium confirmed to me that NHX-SS was compatible with my NHRS model consumer unit. However, I remained concerned because if you compare the NHX devices I currently have in my consumer unit with the NHXL range of devices, you'll see that not only do NHXL lack compatibility with the balcony buzzbar, precluding their installation in DB2, but when placed side by side, their bumholes don't line up, meaning they couldn't mix and match on the same flexible buzzbar in DB1. What's NHXL got to do with the price of fish, and how's it a problem if I'll be changing all my devices in DB1 and putting in a new flexible buzzbar, I hear you cry? Well, I'm not putting the lighting or smoke alarms on AFDDs, so I'll need some 6 amp RCBOs for those circuits. But RCBOs only seem to be available in the NHXS range, at least at cities, and while that ought to marry with George's mythical NHXSS devices, George couldn't guarantee delivery in time for this video. So I went back to my branch manager at CEF, who was able to do me a decent price on the NSX range of AFDDs they had in stock. So, do these NSX AFDDs align with NHX or NHXL bumholes? I need to know in order to ensure the RCBOs I order can sit on the same busbar as the AFDDs. And I'll also need a standard MCB to feed DB2 sitting comfortably on that busbar. So can I reuse any of my existing NHX devices from DB1 or not? Well, not. NXS AFDDs evidently marry up with NHXS RCBOs and NHXL MCBs, but not NHX MCBs or older NHXS BS1 RCBOs, which, like NHX, supports the balcony busbar, unlike NHXL or NHXS. So you may get caught out on site, as I've been in the past, by finding yourself rolling up with a newer NHXS RCBO to replace an older NHXS BS1 RCBO, or an NHXL MCB to replace an NHX MCB, or whatever to replace one of the obsolete NSB MCBs, just to throw that cocksucker into the mix. Christ, what an omni-shambles. Again, this is a nightmare for retrofit, just trying to find the right product that's compatible with what's on site, only to discover the model you bought isn't going to slide into that old consumer unit after all. Why does it need to be this complicated? As one wholesaler account manager said to me, this is why we sell so much Hager stuff. You don't get any of this nonsense with them. The point of sale also claims fits all new and existing installations, and Wylex themselves say this latest product from Wylex can also be retrofitted into existing Wylex consumer units, saving you time on site. Claims which seem to be poppycock if your board has the balcony busbar or the NHX or NSB range of protective devices. They'll only fit if you rip out and replace everything else in those events. The lighting and smoke alarms I'm keeping on ordinary RCBOs, simply because buying 3 6-amp AFDDs will cost over 400 quid more, while 3 RCBOs is about £80. But what's the use of an AFDD on such low current circuits like smoke alarms or even lighting with today's efficient LED lamps fitted throughout? At 230 volts, the current is too low for a series arc to form. You need to be pulling a good couple of amperes or so to get these things to trip, and my loading isn't that. While parallel arcs are still technically possible, a line neutral or line earth arc will likely operate an RCBO in a timely enough fashion, I'm sure. The proposed change to Amendment 2 has an exception for domestic lighting and safety circuits, so I guess 6-amp arc fault detectors won't be a big seller. Anyway, enough talk, let's get this thing stripped out. Okie dokie. And boy, doesn't it get dark quick at this time of year. It's because I've got some charged work lights here, otherwise I'd be in the blackness. And the wife's already a bit annoyed because the power's off to the rest of the house. I'd better get the hell on with this, really, hadn't I? I've got the AFDDs all in. In fact, all the new devices are in. I haven't connected the final circuits yet. That's still to do. And the reason for that is because I wanted to test the current draw that's being pulled by my 9 devices. Obviously, the ordinary devices in there are passive. They don't take any current. Your RCDs, your MCBs, well, you might lose a bit of current through an RCD coil when you've got the load being pulled through it, but it's pretty negligible. But here we have now 9 computers in their own right, all powered on in my board, or at least they will be when I switch the main switch on. The Luden main switch, because the bloody Wylex one doesn't align with my devices, of course. Why Wylex? Why? What a pain. So I've had to, for the moment, grab a Luden switch out of my spares there, which does line up, and I'll have to obviously get the correct Wylex part for that, if I can be bothered. I mean, a main switch is a main switch, really, isn't it? But, oh, bloody hell. Anyway, let's fire up. There's our 9 AFDs all illuminated. These next 3 are RCBOs, and you've got a breaker at the end there. Nothing connected. We've only got the AFDDs on at present. I've got my clamp for my TIS MFT Pro around the incoming tail, and I'm going to use the earth leakage function on here to see what sort of current is being drawn. At present, I don't know if you can see that, 42 milliamp. Now, the only place I can get my clamp on is before the smart meter, so the smart meter is going to be taking a bit. So let's turn that off, and we drop to 13 milliamps. So we'll call it about 30 milliamps that these are taking when they're just there, switched on, not doing anything, the circuit's dormant. You're losing about 30 milliamps for these 9 devices being on. I'm calling it 30 milliamps at 230 volts. That's 6.9 watts of energy being consumed where it wasn't before. That's equivalent to having this 7-watt compact fluorescent lamp on 24/7, or about 2 of today's average LED lamps. So if you're the type of person who gets cross when people go about leaving the lights on, then this may be of note. But how much is this actually adding to my electricity bill? We know 1 kilowatts is 1000 watts, duh, and that billing is by the kilowatt. So if we divide 1000 by 6.9, then we're hitting that billable kilowatt by having these things on every 145 hours, which is about every 6 days. I'm on an economy 7 tariff here, which means I pay more for energy in the day, less at night. That works for me with the electric car, storage heater and other such loads I can run in the small hours, while my solar panels help to take the sting out of the day rate. But anyway, I'm paying 16.54 pence per kilowatt hour on peak and 9.16 pence per kilowatt hour off peak. Economy 7 gives me 7 hours off peak, so I'm on peak for 17 hours a day. With me so far? Good. If we divide these costs by 1000, then we get the price per watt at fractions of a pence. Multiply that by the power I'm consuming over the hours in the day, and we can see these devices are costing me 1.94 pence during a peak 24-hour period, and just under half a penny off peak. So in total, over 24 hours, that's 2.38 pence added to my electricity bill, or £8.69 when scaled up over the course of a year. To put that into electrician terms, that's 4.5 cans of Scouser's Choice. Okay, let's use my super AFDD test instrument that I built in the last video to test one of these out. See if it does the biz. Sure enough, it trips off, and when I switch it back on, we have a flashing yellow light. How well does that come out on camera? Zoom in a bit, can you see that? I can't even tell from the viewfinder if you're seeing that or not, but there's a flashing yellow light there. It's just flashing a single pulse to indicate an arc fault problem, or an arc fault trip. Let's compare that then to an earth leakage trip. Stick that on earth. And we'll do the neighbouring device, shall we, just for comparison. So I'm going to set this to RCD, type A, 1 times, super dupes. Let's stick that on load on circuit 2. Lovely stuff, 78 millisecond trip time, which is well within the 1 time specification, of course. And look at that, we have 3 pulses on that second device, indicating it's tripped off because of an earth leakage fault. 2 pulses, I believe, just consult the sticker, 2 pulses would be an over voltage error, and a yellow and red flashing would be a failed self-test. So that's all rather spiffing actually, isn't it? I'll tell you what. I'll do it with the RCD tester rather than the rather dodgy arc fault tester that I made. This is going to look great. Oh yeah, look at that. Doesn't that look the cock? Yeah. I tell you what, it looks like a computer from a 70s sci-fi flick, that.
What have you found? All I found is that these red lights keep moving back and forth. Aside from that, this thing seems to have no other function whatsoever, sir.
Well, it's impossible. It must have some sort of function. I mean, why would the government put all that money into a thing with red lights that keep going back and forth? Doesn't make any sense. Keep working on it.
Sir, these lights keep blinking out of sequence, sir.
I see.
What should we do about it, sir?
Get them to blink in sequence.
You.
I might not even reset them. I might just leave them discoing away when I do finally get it all back in and working, because that's going to be an icebreaker at parties with all my mates. We are done. 20 to 6, it's getting a bit late. The wife's keen to get on with the dinner, so I've been under the cosh a bit on this one. I was going to talk more about what's inside here and the way the circuits are laid out, but I've got to get the bloody power back on, otherwise I'm going to get divorced. Anyway, this is the... I've still got to change the labelling, of course. The labelling's all completely out of date now. And I've still got some work to do on DB2. I've got to shoehorn in my Twat Cave Wall of Death, so that needs to go in there. So I'm going to leave that off for the moment. But otherwise, we are ready to fire up, hopefully without fiery results. And this will be the first time, of course, that my circuits have gone live with equipment connected on AFDD. So it'll be interesting to see if there's any nuisance trips from the off. There shouldn't be, because I've been through all this, as I'll talk more about later. We are going to see some flashing lights on here because when I was prattling about earlier, I haven't cleared the faults that I put on with my RCD tester or my AFDD tester. Yeah, I'm confusing myself because I'm looking at these wrong labels. Everything on except for DB2. Printer's waking up. And we're back in business. No immediate trips. Excellent. Well, the tool work is done. We are labelled up, still flashing away. I don't want to hit those reset buttons, it just looks too goddamn cool. The Twat Cave is back on, so I'm done with that board. Use my brother labelling machine to just stick a label across there in bright orange, fluorescent orange no less. It's corporate colours, and it also helps to obscure the old labels that are behind it. As I say, we should change out that main switch really for a proper Wylex one, but anyway, we're in, we're on, the lights are on, the wife is cooking, brilliant stuff. A quick run through of what we've got here. I've got a 40 amp AFDD for DB3, which is my shower and car charger. If anything's going to fail on an arc fault, that's a high contender, because we've seen shower isolators, I'm sure, in the past that have burnt out, so that's one where it may happen in the future. Similarly, the one neighbouring it, which is the water heater, the immersion heater, I've had problems with that before, with the timer controls on that. And in my test and inspect last week, I did find a loose neutral on that, but it's all nice and tight now. For some reason, it never seems to stay that way. So, well, again, that's these two here are the ones that my money is on tripping in the future should something go wrong. Solar PV is next, 16 amp breaker. These aren't arranged in order of size, they're arranged in order of where the cables were inside the board. Obviously there's no point extending a cable to bring it over here just to keep the breaker in size order. It's the busbar is capable of carrying 100 amps, it's a 60 amp supply anyway, so it doesn't really matter if I've mixed them around a bit. The original house socket ring, the office socket ring, and yes, they are rings here, I didn't put them in. The induction hob, the upstairs heating, that's something that went in after I got rid of the gas system. So there's a couple, I think one underfloor heating solution up there and some panel rads, all hanging off a 20 amp breaker. What else we got here? Kitchen ring, oven, lights down and landing, the smoke and intruder alarms, lights up, and then the feed to DB2. Obviously these last three here, lighting and intruder alarms, as I said before, are just RCBOs, no point putting them on AFDDs, and this is an ordinary breaker feeding DB2, because as I said, I don't want my Twat Cave on an RCD, and this is just the surge protector breaker here. Surge protector is still showing good. Marvellous. So I'm going to leave that flashing away and we'll see how things go. One other thing to add, I suppose, obviously these are now all segregated, so there's no common RCD protection like there was before, where one circuit could cause this sort of single point of failure to take out a group of other circuits. Any earth leakage faults now are only going to affect the particular device that circuit is on. And one of the things, well, these are now all Type A devices. Before, the RCDs were Type AC. You can see the AC waveform there. These are now all Type A. So any a certain amount of DC leakage onto any of these circuits, and it should still retain its earth fault leakage protection. The mandating of Type A's over Type ACs is something you may well see coming in Amendment 2. So, well, I'm pretty bulletproof apart from the old plastic casing. But I've got the sticker up there to say what the fault indicators are, and I've got my new Test and Inspect sticker on there because I will be providing a new installation certificate, a new Part P certificate. Yes, why not? Maybe I should film that. And that's that signed off for up to another 10 years. I'll stick a 10-year ticket on that. With regard to my Garo unit, that already has a 40 amp, 30 milliamp Type A RCBO installed for my shower and EV charger, so having another device of the same rating in line isn't best practice and doesn't comply with what BS 7671 says about selectivity. But that's not really a problem here, as the two devices are right next to each other. That sort of thing is more of a ball ache where you have, say, power to an exterior building with a 30 milliamp RCD inside the house and another at the outbuilding itself. In the event of an earth fault on a final circuit here, one or both RCDs may trip and all bets are off as to which may react the quickest. It's not necessarily the one closest to the fault. Ambient temperature, tiny variations in component tolerances and manufacturing, moisture levels and foreign particles are all examples of factors that affect the reaction time when these things need to mechanically operate. You're not meeting the requirements for selectivity if you can trip a device that's not local to the circuit it's protecting, such as if you're working on the outbuilding and have no access to the house. Anyway, that's by the by. I only mention it here in case some smart ass brings it up in the comments. My AFDDs are only monitoring the distribution wiring for the most part. With the appliances, anything on the output side of a transformer, opto-isolator or whatever is invisible to the AFDD. I've shown previously that my Jacob's ladder, whose very purpose is to create a fuck-off great series arc, can do so while happily sat on an AFDD, because although the device will trip if an arc occurs on the primary side of the transformer, what happens on the secondary side stays on the secondary side. This means an appliance is only likely to cause an arc if the fault is on the flex or on any components with a direct connection to the supply. This is where it could cause problems later on, even if things look rosy right now. Recently, Neil Bridgman was on Twitter scratching his unfeasibly large head over a perceived AFDD trip with the use of his dishwasher, and this is where hidden problems may lie. For those who saw my pat testing video, you may recall my washing machine example where a motor and heating element are present and a fault on either could cause nuisance tripping, of an RCD or AFDD as it happens. The problem is, even if you hook up a portable appliance tester, these components are on the wrong side of a PCB and simply aren't connected when the appliance is not powered, so it can pass a test despite having a fault. Only at a certain point in the operational cycle do these components get switched in, and that's when your protective device will operate. Similar to upgrading an installation to RCD protection where it wasn't present before, there's the risk that appliances which were previously perceived to be working without issue now trip off the device on certain settings or at a certain point in their cycle. Of course, that's seen as your fault, as it was all working before you put that stupid new consume unit in, but there's little you can do to mitigate against that. The most diligent EICR and the most robust PAT inspection won't pick up these sort of issues. I may yet experience an AFD trip the next time the washing machine is used on a certain program, for example, and I recall some drunken idiot up to his elbows in that particular appliance just a few weeks ago, so all bets are definitely off there. As far as the distribution wiring goes, I was pretty sure I'd be safe here, as last weekend I performed a rather robust inspection and testing of the place to see how well it compared with 2012's numbers. We'll look now at how I limited the risk of there being any pre-existing ARC fault issues to allow me to confidently undertake this upgrade today, and how we can potentially go about tracing an ARC fault should one of these devices now start tripping. When the RCD trips, we can use insulation resistance testing to track down the problem. But when it comes to inspection and testing of an installation prior to a CU change, narrowing down a likely ARC issue requires some extra testing most people aren't currently undertaking as part of the condition reporting process. Let's use this socket radial as an example. It's a 20 amp circuit wired in 2515mm twin and earth, and we've undertaken an electrical inspection where we've identified 5 outlets that it serves. Our aim post-installation is an upgrade of the fuse box to a modern consumer unit with overload, residual current and arc fault protection. We didn't install this circuit, so we don't know the cable run, its history, or if it serves other points of utilisation we haven't seen, perhaps something behind fitted furniture, or maybe it served another outlet in the past that has since been decommissioned. I don't know, this is our first visit to the property. As part of our inspection and testing procedure, there are 2 dead tests we already perform on this circuit as part of a competent EICR, which will help in checking for potential ARC faults. Insulation resistance testing may pick up damaged insulation between cable cores or live parts to earth, and we're already used to performing IR testing to ensure RCDs won't be troubled. If the EMF from the test instrument, usually at 500 volts DC, can short from line conductors to earth and give a failure reading on the tester, then you can expect RCD or AFD tripping through parallel arcing if the upgrade goes ahead. The pain with IR testing for parallel arcs comes with the potential for such a fault to be present on a damaged cable between line and neutral, as that test is often a limitation on an inspection. As an example, the latest inspection I performed on my own home has line neutral IR testing limited for lighting and sockets. Those tests were undertaken in 2012 and they passed back then, but my installation is now more complicated than it was in those days, with USB sockets, bespoke RGB lighting, smart switching and all manner of permanently connected gizmos that I would have to wire out to prevent the test result from being skewed. As such, despite the fairly thorough inspection performed here and the data collated, there remains a risk of an existing parallel arc fault between line and neutral being present on those circuits whose testing has been limited. If I experience nuisance tripping on one of my limited tested AFDD circuits, which persists after all fixed equipment has been wired out, then IR testing between line and neutral is my next port of call. But as I mentioned earlier, if I have such a fault with enough energy present that arcing can occur between line and neutral, well, there's a good chance the overcurrent protection will be kicking in anyway. For me, series arcing is really where these devices come into play, as that's something a breaker or RCD isn't going to prevent. On an inspection, we're reliant on identifying its potential presence by seeing a bad resistance measurement, and here's where it gets a bit sticky. Let's say our radial socket circuit here is 20 meters long. Appendix I of the on-site guide tells us that a 2515mm cable has a resistance of 19.51 milliohms per meter. So at 20 meters, we should see an R1 plus R2 reading of 0.39 ohms at the circuit endpoint. It may be very slightly higher to account for the fact the cable has been cut into at multiple points along the route to terminate into the other accessories, but if we see a reading of about 0.39 ohm and we believe that corresponds with the circuit length, then we can all start backslapping and sucking each other's cocks, as the result expected is the result obtained. Marvellous! However, the electricians who installed the circuits on my house are probably all dead by now, and I doubt if they were still around they'd recall the length and route of the wiring, so we're not going to know the precise length of any given circuit in order to be able to confirm our readings are correct in most properties. Let's assume then that at what we believe to be the circuit endpoint, we don't get 0.39 ohm, we get 0.95 ohm. The maths says that corresponds to a circuit length of over 48 meters, so alarm bells are ringing if you're in a small abode, especially if previous accessories were checking out with numbers that better met expectations, as that suggests a loose connection, and loose connections are exactly what's supposed to upset an AFDD. We can of course open up the accessories we've identified on that circuit to check connections are tight, cores aren't fractured and sleeving isn't caught, all the things that cause this type of high reading. But what if that high reading remains after you've checked and verified every other point you can find? Maybe you shrug your shoulders as it's still a pass. We know the maximum rating for this circuit is 1.75 ohm for the B20 device protecting it, and so long as our external impedance in this case is below 0.8 ohm, then our endpoint reading of 0.95 ohm can be seen as being within tolerance. But this being a 20 metre circuit means what we have here is a potential loose connection that's likely to worsen over time. And if you want to be assured that arc fault devices aren't going to cause you any trouble either immediately or further down the line, you're going to have to know for sure that your readings are right. And the way to do that is to also measure the neutral. Yes, often the only time the neutral is considered when an ohmmeter is waved around is R1 plus Rn testing on a ring circuit. And even then, that's usually on initial verification when commissioning a new circuit rather than ongoing inspection. If you've taken your R1 plus R2 to verify the line in CPC, how many of you then perform the same test either as an R1 plus Rn or an Rn plus R2 on both ring and radial circuits to verify nothing's untoward on the neutral? Yeah, if you're retrofitting AFDDs, get used to doing that, because if you're just verifying the line and CPC, you can expect AFDD tripping trouble to occur just as easily on the neutral side, and Sod's Law says that's exactly where it'll happen. In fact, for those of you who've changed out fried shower isolators and water heaters with any regularity, how often has it been the neutral that you found cooked rather than the line? More often than not in my experience. The model form has many undertaking EICRs so focused on filling out the boxes in front of them, they overlook any resistance testing on neutral because there's nowhere to record the result, and perhaps that's something that needs to change on the model form with Amendment 2 if AFDDs are being pushed. It's certainly something I've raised on the DPC, so if it happens, sorry, that may be my fault. It's not enough to know the earth fault loop path passes on an ohmmeter. You also need to be sure the number you're getting is right for the circuit length, and that the neutral is also sound. So after your R1 plus R2, you need an Rn plus R2, which should give you the same result, thus verifying all the live wires are sound in their connections. In this example, Rn plus R2 gives us a completely different figure to the 0.95 ohm recorded for R1 plus R2, potentially indicating the neutral and CPC are good, but there is a loose connection on the line, and that the 0.95 ohm figure we recorded isn't the glittery pass we thought it was. Obviously, a loose connection on R2 could be throwing both results out, but you perhaps only need to worry about that if both results seem high, as R2 isn't likely to trouble an AFDD, it's there for fault current, and any such current ought to trip the breaker or RCD in short order. Still, for the sake of shits and giggles, if both R1 plus R2 and Rn plus R2 are giving us a high reading that seems unlikely considering circuit length, 0.95 ohm here indicating a circuit length of 49 metres, then we could measure R1 plus Rn. According to table I1, two cores each of a cross-sectional area of 2.5 mil would have a resistance of 14.82 milliohms per metre. So if the circuit really is about 49 metres long, as our previous result suggested, then an R1 plus Rn result should come out as 0.73 ohm. If all the numbers marry up, you're home and hosed. If not, you can use these additional tests to identify which core has the potential loose connection.
Really, these additional tests should be performed as part of any current EICR anyway. Otherwise, you're not verifying the neutral at all, and you have no way of knowing the R1 plus R2 figure really is correct for the circuit. But the form doesn't ask for it, so it doesn't tend to get done, even by those undertaking diligent inspection and testing. That's where this sting will come with AFDDs though. I've put up videos this year showing what poor EICRs undertaken by charlatans look like, and how they're used by the cowboys to create work that may be unnecessary, especially new consumer units being poorly installed in place of older models that didn't necessarily need changing. But things may get interesting for the cowboys from 2022 if AFDDs do come off. Any chancer who thinks they can bash out a fake EICR, failing an installation specifically because the consumer unit lacks arc fault protection, then who smugly sticks a new box on the wall packed with these things, had better take cash in hand and not leave their phone number behind, as they may find they can't get the power back on afterwards.
So anyway, what if all this resistance testing identifies there is a fault?
On our circuit, perhaps we're getting 0.95 line to CPC, 0.39 neutral to CPC. That lower number suggests the CPC and neutral are where they should be, that the circuit length is 20 meters, which appears sensible based on the proximity of the accessories to the consumer unit in this example. So we can determine we have a high reading on the line. Arcing isn't going to occur over a resistive fault this low, but if a loose connection is present, it's likely to worsen over time until it starts going open circuit, where the trouble will really begin. But let's say we've identified that we have a problem here, and we worked our way back, checking all other accessible connections, and yet we found them to be sound. That potentially means either there's another point in this circuit we haven't located, such as a junction hidden somewhere inaccessible, probably under the floor or something lurking behind fitted furniture, or there's damage to the cable as buried in the fabric of the building between the last point which read good and the next one which is bad. The trouble is, we don't know for sure the route of that cable, and running a new cable or accessing where a junction or otherwise inaccessible point may be located may be wholly impractical.
And this is where we need AFDDs to be non-mandatory. If I have a high reading that's nonetheless still within limits at this point, this is where I need to be able to say to the homeowner that I think I've identified a poor connection on this circuit that may go on to result in either a failure or high temperature arcing, which is of course a fire risk. But I need their permission to put that right at whatever cost for my time and materials, and potentially for other trades to make good after I've pulled up their laminate floor or knocked holes in their walls. Of course, they're going to think I'm making it all up, as everything is working. But ultimately, the decision is theirs to make based on their own risk assessment of cost and disruption versus taking their chances that it's never going to cause them a problem. I can't force them to have their house pulled apart to put it right, and I can't demand a circuit is decommissioned based off an R1, R2 result being out. I also don't want to place myself in a position where I'm worried the circuit protection I'm putting in may result in nuisance tripping that's going to inconvenience my client and lead to them making shouty phone calls to me for a fault I simply don't have their permission to fix because they just can't afford it, and getting under anybody's floor isn't going to be cheap. Obviously, if an AFDD does go in and it starts tripping, then it's doing so for a reason, prevention of fire being a bloody good reason. Nonetheless, options need to remain open between electricians and their clients to ensure what goes in represents the best solution to suit the available budget. And yes, loose connections cause fires, but not every loose connection leads to a fire. The vast majority of them go unnoticed until they result in a failure open circuit or other obvious effects such as audible crackling and intermittent operation, and that's when the electrician is usually called in.
There are situations where the use of AFDDs, if mandated, would be pointless, as in a recent example I gave while discussing this on the SGTV channel. Take this consumer unit located in a broom cupboard. Full RCBO and RCD protection, that's nice. The client wants a socket outlet to be mounted adjacent to it for charging their cordless vacuum cleaner. As someone appointed to undertake the work, I have several ways of doing it. I could break into existing socket wiring so that this new point runs from a circuit already present, although I'd have to fully test that circuit in order to certify the work. I could install an ordinary 16 amp breaker into one of those spare ways and put in an RCD equipped outlet. Or I could install a 16 amp RCBO in one of those spare ways and put in an ordinary outlet. Those last two options may cost a little more in materials, but ought to be less faff, as I wouldn't be having to check and take on the responsibility for any existing circuits, and besides, junctioning into the existing wiring may be fiddly. However, if I do utilise one of the spare circuit ways, this becomes a wholly new circuit, albeit a very short one serving only one point. Mandating AFDDs would mean I'd have to install such here, which would be a nonsense. The intended load is never going to be high enough to cause an arc fault. Only if someone plugs in an iron or kettle and a loose connection has managed to form on this very simple circuit would it be needed. As the designer of this solution to the client's needs, it makes no sense to go to the expense of installing a computer into this consumer unit to monitor the trickle charging of someone's Dyson, especially if the CU lacks surge protection, and I'm not sure I trust the electronics in an AFDD to last long in a non-SPD board. I should be able to apply a risk assessment to my designs to determine whether an AFDD is beneficial. It's this kind of bumfluffery where the regs can say what they like. In this sort of situation, my certificate will simply list it as a deviation and be damned with it because common sense will be applied. My goodness, this is a waffly video. For anyone still listening, I'll show you the results of my own EICR from last weekend. I've compiled them all onto one schedule, despite there being split over 3 boards, but that's just for ease of display here. Now that the upgrade is finished, I will author a new electrical installation certificate to cover all this, of course. A few things of note: no RCD testing took place last week because the RCDs were to be decommissioned, of course. As already mentioned, line to neutral IR testing has been omitted where it's just too impractical to wire out all the fixed loads, and I've omitted ZS testing where I can't safely connect my MFT via a plug and socket arrangement. Crucially, as I showed earlier, I've measured Rn plus R2 per circuit to compare it with the line figure, and I've calculated circuit length based on those readings. And it's a good thing that Rn was checked, as I found poor connections along neutral both on my immersion heater and on one of my underfloor heating supplies, which, being resistive heated loads, would likely have tripped up the AFDDs employed on those circuits at some point. There's one result I'm not happy with, and that's the CPC end-to-end on the original house socket circuit. I've put this down as a 2515 cable, but it's imperial, so the result may be out by more than a factor of 1.67. But with R1 and Rn each being 0.55 ohm, having R2 clocking in at 1.34 ohms is pretty far out. This is an example of the kind of problem I talked of earlier. I've been around every accessible accessory and verified connections are good, yet the testing indicates a poor connection on the CPC somewhere. This was also noted on the 2012 inspection, and I couldn't find the fault then either. My suspicion is that it's below the bathroom floor, as the bathroom was refurbished and extended in 2005, resulting in the relocation of a socket outlet on the landing, which I suspect the builder performed himself. That landing socket would originally have been on the ring, but the relocated socket is a spur, so I think we're looking at a moody screw terminal box lurking under the lino. The wife's been nagging for a new bathroom for some time now, so when that happens I'll be able to dig down and find out for sure. Until then, there's not much I can do about it, but I have verified a good earth fault loop path at all accessories on that circuit, and the CPC won't be carrying current under normal operation, so it's not a factor with my AFDDs today. But what if that bad number had been on R1 or Rn? If I can't get to where the fault is, I'd have to look at perhaps breaking the circuit down at the fault position, if it can be confidently identified, into 2 lower rated radials in order to be able to remove the problem and apply the AFDD upgrade. Except now you're paying for 2 AFDDs to cover what was 1 circuit, and you need space in the board to accommodate such. Oh well, such is life, and that's why we undertake thorough inspection and testing before any consumer unit upgrade, rather than turning up with a pre-populated board and winging it on the day.
This upgrade has been quite the financial kick in the balls, but the prices will plummet and the depreciation on my investment today will be massive. These items will have to retail somewhere near today's RCBO prices if they're going to be viable from 2022, and manufacturers will be keen to get you used to their particular product, so let price wars commence. Otherwise, if this kit stays at today's price point, we're just not going to fit them, despite what 41.1.7 says. You know that details of departures field on the electrical installation certificate? We'll get used to writing regulation 421.1.7 for the installation of AFDDs has not been complied with as the client lacked suitable budget for the hardware, or words to that effect. In terms of population, I've seen comments recommending AFDDs or even RCBOs not being sited together in consumer units in case of a build-up of heat. I've not experienced any problems with RCBOs overheating, and I know of no manufacturers stating that a circuit way needs to be left blank between RCBOs when they're employed. I would suggest that if this were a thing, then manufacturers would make consumer units with a blank built-in between circuit ways and a busbar spaced so as to prevent devices being directly neighboured without an air gap. There's nothing in the instructions accompanying my devices to say I can't cram them together. If I upload a video in 6 months showing some of these reporting a failed self-test, well then that will probably speak volumes, but part of the experiment here is to see what the heating effects are. Prior to conversion, the interior of the dual RCD configuration was around that of room temperature. Now that it's been in and operational for a week, I can report the internal temperature is a few degrees higher, no real surprise there. Using a laser thermometer, we can see the AFDDs show a higher surface temperature than the simpler devices like the main switch, MCBs and RCBOs.
Before I wrap up on AFDDs, hopefully for good, as I'm as sick of rambling on about them as you are of hearing me ramble on about them, let's have a quick flick through some of your questions and comments. Charlotte Robinson says, I could get behind AFDDs a bit more if it was one AFDD protecting a number of circuits, similar to an RCD in a split-load board. Certainly, that would reduce cost, and an AFDD can monitor multiple circuits. It's looking for a telltale arc signature on the current that it's monitoring. It doesn't care if that current is serving multiple circuits. That said, the whole RCD protecting multiple circuits thing never did sit well with sticklers for Regulation 314, which requires circuits to be segregated so that if one has a fault, it doesn't pull down anything else. An RCD protecting a group of circuits represents a single point of failure for that group. And although 18th edition laid that argument to rest in 2018 by introducing new regulation 531.3.5.2, specifically permitting a single RCD to protect multiple circuits in a TN system, it's telling that in the amendment to DPC, this has been pooed on, with the wording changed to say RCDs shall be installed at the origin of the installation, and no mention of them serving multiple circuits anymore. Instead, it refers back to 531.3.2, which now proffers the use of RCBOs for the first time. This is a positive move against dual RCD boards and the whole single point of failure problem. The regs are trying to get us to eliminate that from our designs, and about time too. So you're not going to see them now introduce AFDDs in the same way, as that would be telling us to remove one problem while introducing another of exactly the same nature. Also, getting called out to an RCD trip is something one can fault find on using some insulation resistance nonce to quickly narrow down which circuit is your smoking gun, whereas trying to locate an intermittent AFDD trip across a group of circuits would be a fucking nightmare. You're looking for a loose connection somewhere and you don't know which circuit to even start with. To hell with that. BigClive.com, yes, even he says, I'm not convinced it's a great idea to stuff more active electronics with progressive failure modes into consumer units. I can understand the need for an arc fault interrupters in the USA, where their home wiring represents a cheap welder, but in the UK our higher voltage tends to be more decisive when arcing occurs and quickly gets the earth involved, resulting in RCD tripping. The Americans don't generally have RCDs in their DBs. I think as well that the problem with AFDDs is it's impossible to determine their effectiveness. Numbers get thrown around from the manufacturers about electrical fires, but not every electrical fire will be prevented by the presence of an AFDD, and when an electrical fire does occur, the absence of an AFDD is no guarantee that it wouldn't have started. Take the spate of Whirlpool dryers that have been causing fires over the past 5 years. Those would all be classed as electrical fires, as they started in a running appliance. But the problem there is apparently down to fluff getting onto the heating elements, which has nothing to do with your distribution electrics, and won't concern your AFDD or anything else. At least, not before the fire starts, spreads, and then melts the bloody cabling. Steve Jones says, it seems to me that there's another major cost issue with these AFDDs, and that they will need considerably larger CUs, and that given where these things are often installed, there simply won't be room. That means relocating the CU, and that can be a very expensive and disruptive exercise. Cost and size are indeed the bugbears at present, and although the former will drop with volume of sales, trying to install larger enclosures to accommodate extra gubbins is difficult, where that was never a design factor in how the property was originally built. I believe it's only Electrium who have the single module mini RCBO size form factors out today in their Wylex and Crabtree ranges, and JW showed an MCG model in a single module full height form. But most brands are currently dual or even triple module, so yes, retrofit is where the pain is. My retrofit here has been relatively straightforward because I'd already relocated my CU to where there was more wall space, but in most existing homes we're expected to shoehorn a replacement CU in some tiny understairs cupboard where the old fuse box lives, and relocating it isn't a practicable option. I also question the timing of this potential change, being as it is only about 18 months from now. Few manufacturers seem to have AFDD solutions ready to market, and that explains why prices are being held high at present. Will Eaton and Schneider be able to shrink their existing 2 or 3 module designs into one by 2022? Are Hager working on an RCBO/AFDD combination unit? When can we expect models from big brands like Contactum and Luden? Will budget brands like Axiom and British General have any such devices on the market in time? Things are going to need to move fast in 2021. Bill Byron has some interesting information on how these work and how they've caused trouble in the US with false positives from ham radio receivers. Breaker, breaker, good buddy, I've got a Smoky on my Bandit 10-4. Oh bollocks, my AFDDs tripped. A cursory look over the interweb confirms problems, especially with earlier models, although as I said previously, I don't know if the American things are of a simpler design considering how long they've been out for and their price point. I would hope lessons were learned regarding external influences when the likes of Siemens started stuffing ARM chipsets into RCBOs to monitor for suspect frequency signatures. So I guess we'll see what happens on this side of the pond. Mathman has more detail on the improvement in reliability and also provided 2 links I've included in the description to an AFCI tester marketed by Klein, which is perhaps more presentable than my pedal bin model. It'll be interesting to see if that shows up on these shores. And he also links to the history of American AFCIs. Wayne Roddis Clark wonders if these will be brought in for new installations only and not for fitting onto existing installations. That would perhaps be a compromise. Start putting them in on known good wiring as part of a new design where their cost and space requirements can be accommodated. Of course, it's the older installations that are creakier and more in need of the protection these devices offer. But if they're out of the price range of those who previously haven't been able to afford a better standard, how are they now going to fund the old fuse box being decommissioned, their tails, earthing and final circuits extended to a new position where a larger board can fit, the house scoured for loose connections with remedial works to put right, and the cost of new hardware once we know it can all go on the wall without nuisance tripping? Yes, AFDDs for new designs only. I'm on board with that. And allow us to give options to homeowners on a budget. Even on new designs though, if we go back to my example from earlier, I've shown a Crabtree Starbreaker board here, and it happens that a single module Crabtree AFDD can be sourced and fitted if really needed. But what if this were another brand of consumer unit such as MK? Okay. They were a popular choice for years, but MK left the consumer unit market quite recently, probably because they looked at the regs requiring SPDs, AFDDs and Type A RCDs and thought, to hell with the R&D on this. So I presume MK aren't going to be making AFDDs for what are now obsolete boards. So from 2022, if I have to install a new circuit and there is no supported AFDD for the existing board, we'll be looking at requiring a CU upgrade or a secondary enclosure containing the tech which is up to snuff. I guess that's okay. It's been the same for years where RCD protection has been required and you don't want anything to do with the existing electrics. A lot of people already have secondary enclosures as they had a shower, extension, new kitchen, EV charger or solar PV added on in recent years. So you may end up changing out that secondary enclosure or even adding a third. Crikey. Martin Wright says, so up to 32 amps? Most common arcing I've seen is on shower circuits which are 40 amps and above. Am I missing something? Well, we both must be, Martin, as I don't know why the draft changes for circuits at 32 amps or below when it's 40 amp showers and cookers that see the most thermal damage from poor connections in my experience. AFD devices need a good couple of amps to operate, so a loose connection on your LED lighting will persist all day long without the fucker tripping. It would make more sense to recommend them on circuits of 16 amps or above. Mark Bitchum raises the concern that these changes price we legitimate installers out of the running, which is a fair point. As far as Joe homeowner is concerned, a consumer unit is a consumer unit, and so long as his lights, his beer fridge and his Xbox all turn on, he doesn't give a fuck about how it works. A quick browse through the Screwfix catalogue will turn up bargain basement CU models, which will probably still be around after and despite Amendment 2. AFDDs, like metal consumer unit enclosures, are just another sticking plaster solution. The industry should be recognising that standards of workmanship have fallen because of a lack of oversight and accountability. So long as there's no formal registration in the UK for electricians, and the competent person schemes remain happy to not to keep too close an eye on their members, or to step in righting their wrongs when they're uncovered, then you can expect shoddy installation and maintenance to continue. AFDDs and metal enclosures are a shoulder shrug to say, let's try to stop the fire from loose connection when it starts, rather than there being an industry shake-up to put the clueless or the cowboys out of action. Stop coming up with new ideas on how to contain the disaster when it happens and do something to raise the bar. This is yet another cure over prevention.
If the aim is to cut down on electrical fires, start by mandating EICRs and properly accrediting who should be doing them. Make it a clause of standard home insurance that payouts for electrical fires, shock injury or failed equipment is perhaps at risk if you can't prove the electrical installation is properly maintained. Maybe lower premiums for those who can produce bona fide paperwork. Andy Fletcher brought up concerns on the running costs of the devices themselves, something I addressed earlier, and as he says, scale these things up across millions of installations over the coming years, and it all adds up to a lot of extra juice. AFDDs then. Well, there shouldn't be a blanket mandate to install them in my opinion. It's up to the designer to determine which protective devices are appropriate to meet the needs of the client. If you agree, then make yourself heard on the BSI website before 11th December, or forever hold your peace. Amendment 2 is also proposing the removal of risk assessments for emitting RCD protection on socket outlets, which again seems all a bit nanny state. We adult professionals are capable of making our own design decisions, for fuck's sake. Ultimately though, so long as the DIY stores continue to flog low-cost, pre-populated consumer units to any asshole who waltzes in brandishing a credit card, then you can expect technologies such as SPDs and AFDDs to be ignored. I stopped competing on price a long time ago on EICRs and consumer unit installations, and with all the additional arsehole being proposed, I might well exit from such markets completely. Who needs the hassle? Someone else can do the work, I'll come along afterwards and fix the faults. Why not? By the time someone's AFDD is tripped for the 15th time that day, they'll pay whatever I ask to put right the fault that their cheap-ass installer didn't look for before they undertook the work. Anyway, I know it's been a particularly long one, so thanks for persevering. Before I sign off today, I'd just like to pay my respects to industry legend Tony Cable, who passed away last month. I didn't know him personally, but over the years I'd caught many of his appearances at shows such as Wylex and CEF Live, where his knowledge of the industry and enthusiasm to pass that on to the next generation was an inspiration.